the main component of the system, which is the tank containing water. This is just the protective casing of the tank. The tank itself is a cylindrical glass tank into which there is cold water inflow in all of the experiments. The cold water inflow is managed through this valve, which needs to be opened prior to the experiment. The cold water inflow is controlled by a pneumatic valve which operates with air supply, and therefore at the start of every experiment the air supply needs to be turned on as well. In all cases in this lab, on is signified by the handle of the valve being parallel to the pipe and off being signified by perpendicular to the pipe. So since we need it on, let us just keep it parallel. The outflow from the cylindrical tank in most of the systems is two outflows. One, the shorthand valve, and the other being the longhand valve. As you can see, the longhand valve is a direct drainage, and the shorthand valve is a drainage which basically takes more time to drain the liquid from the tank. The level of the tank is measured by a differential sensor, whose plate you can see up there, and the flow meter acts in a similar way. The tank is provided with a heating coil, as you can see here, through which steam is passed in order to heat the liquid in the tank. This is the pipe relating to steam flow into the tank and out of. In order to operate steam inflow into the tank, you first need to open the main steam supply, as you can see there. Once that is open, steam flows through this insulated pipe into the coil, heating the liquid inside the tank. And this is the condensate pipe, which, as you can see, is not insulated and therefore must be treated with caution. And this joins into the drainage as well. The drainage from the tank as well as the condensate pipes all connects to the main drainage line, and therefore this valve must be checked that it is fully open before the experiment starts. At the start of each experiment, make sure that you switch on your cold water inflow as well as your air inflow, and make sure to turn these off when you are done with the experiment. Similarly, if you are using steam in this experiment, only then turn on this main steam supply and make sure to turn it off at the end of the experiment. The second tank in the system in these labs is not used for any of the experiments in the CHE446 labs. So in that sense, it only serves as a drainage holder. So in this lab, we have three systems, P1, P2 and P3. P1 and P2 have a similar structure as I have just shown you. Station P3 is a little bit different in the way that it is built. The first difference is that there is only one tank instead of two. But that makes no difference to us because this is the main system under consideration. The second difference is that there is no longhand and shorthand valve right underneath the tank in P3. Instead, there is just one drainage pipe that is operated by this valve. So there is only one valve in P3. So each station in this lab is operated by its own computer terminal, in which we have the Delta V system installed. The Delta V system is what sends the commands to the valves and other operational elements inside each system. This is a schematic of the system itself. As you can see, we have different variables: cold water in, steam in. We have a schematic of the tank with the level sensor measurements, with a temperature sensor measurement, flow sensor measurement, steam flow, sensor measurement, and so on. So this gives an overall picture and data acquisition and storage for each of the systems in the lab.